Hi everyone, thanks for joining. We're just gonna give it a couple more minutes, wait for a few more people, and then we'll get going.
Just going to give it another minute just to see if anybody else joins, and then we'll jump straight into the presentation. Okay, good afternoon. Welcome everyone. Thank you for joining us today and taking time out of your busy schedule. I'd like to start today's webinar with introductions. So who is Orbital Net? We are a national internet and telecoms provider with our head office in the southeast and a second office based in the southwest. Today's webinar has been created to help you understand the connectivity and telephony changes that will be coming so you can prepare for the big connectivity switchover. My name is Ian. I'm a customer success manager here at Orbital. I have worked in multiple industries like retail, care, transport and wholesale, and I have a great understanding of the impact that poor connectivity can have on your business. Joining me today is Kimberly Bray, also a customer success manager with a wealth of knowledge in the education and events management sectors. Our objective is to provide you with guidance and useful information so you can make informed decisions regards the connectivity switchover and how to move forward. You may have heard about the big switchover or acronyms like PSTN and ISDN, which can be confusing. Today, we want to explain what these are so you can make informed choices ahead of making any decisions or changes to your connectivity or telephone solutions. So today, we will be covering what the switchover is and why it's happening, the timeline of events where we are currently, the implications to you if you do not change, the connectivity that is replacing older, outdated solutions, how digital phones work, the advantages of digital phones, the internet options that are available, the advantages of fiber internet. There'll be a little bit more about Orbital and how we can help you. And to finish, there will be a Q&A session at the end. So let's get started. What is the switchover and why is it happening? Let's take a step back to the 1800s, where the telephone was invented, connecting you from one person to another via a copper wire. This was a manual task carried out by a switchboard operator. This process is known as PSTN, or Public Switch Telephone Network. You don't need to remember the term PSTN, you just need to know the process connected was a switchboard operator manually connecting the copper wires, allowing you to talk to the receiver on the other end of the phone line. As said, this was a very manual task. With changes in technology and the digital revolution introducing computers, this manual process could become automated, and the ISDN, or Integrated Service Digital Network, was launched. Moving a bit further into the future, around the year 2000, mobile phones became popular. A lot of businesses were no longer using their traditional landline as much. Businesses started using their internet connection for their telecoms instead of the traditional system, as it can offer many enhanced features that a traditional copper line can't. Additionally, due to the age of the ISDN and PSTN network and the volume of people connecting, it started to become unreliable. So BT decided to discontinue the traditional service that we have become familiar with in favour of a more digitalised approach. So in 2015, BT announced they were going to stop all analog phone systems. We received a notification that we were no longer allowed to sell these products to our customers. Openreach also announced the full fiber FTTP rollout to future-proof connectivity as we move to digitalized solutions that require faster and more reliable connectivity. They launched SOGEA, which stands for Single Order Generic Ethernet Access. This was launched as a replacement for a service you might be familiar with called FTTC, or Fibre to the Cabinet, while we're waiting for the fibre to be rolled out. SOGEA allows the internet portion of your phone line to be used without the copper portion traditionally used for making phone calls. The next event in the timeline was the 5-year reminder that BT would be removing the copper connectivity, and this is where things started to escalate. In 2021, we received the official stop sale announcement, so we could no longer sell analog-based products. There was a need to migrate millions of businesses to a digitalized system by 2025. So that's where we are now on the timeline, and we're still not quite there. There is still millions to migrate to a digital platform. So BT has extended the deadline to 2027 for the most extreme and vulnerable cases. So what are the implications if you choose to migrate your analog services at the last minute? If you choose to delay upgrading to digitized solutions until the last minute, you could risk losing your phone system altogether. This is because you need to switch from an analog to a digital platform whilst the copper line is still live. If you want to keep your existing phone number, this will need to be ported over before the switchover. Businesses relying on traditional PSTN or ISDN lines for telephony, alarms, fax machines, payment terminals, and even lifts may face sudden outages or degraded performance if these services aren't migrated to digital alternatives in time. A last-minute switchover can lead to unexpected downtime, poor internal and external communication, and delays in operations, especially in sectors like healthcare, logistics, or retail, where time-sensitive communications are vital. Even if your copper line is good for now, there are no plans to replace or maintain that line, so the call quality will eventually degrade, though it's important to have enough bandwidth for the calls, otherwise this can also cause degradation of the call quality. This is also why it's important to upgrade your internet connection. As the deadline approaches, demand for engineers, hardware, and installation slots will spike. Businesses that wait may face higher upgrade costs, longer lead times, and limited availability of preferred vendors or service providers. Older analog systems often lack the cybersecurity protections of modern digital solutions. Delaying migration can leave critical infrastructure more vulnerable to breaches, particularly where remote access or legacy systems are involved. Many new systems like cloud-based telephony, VoIP, or modern alarm systems may not work over the old PSTN or ISDN infrastructure. Without preparation, businesses risk investing in new technology that isn't fully compatible, or worse still, halting services altogether. Preparing early allows businesses to adapt scalable and flexible cloud-based communications and collaboration tools. Those who delay miss out on efficiency gains, cost savings, and future-proofing infrastructure. Some businesses, particularly healthcare, finance, and public services, may fall short of compliance or service level agreements if communications are disrupted, resulting in reputational and financial consequences. But what are the options? So what is it all going to be switching to? It's going to be moving across to VoIP, which stands for Voice over Internet Protocol, which basically means you're going to have an internet phone and you're going to plug that directly either into your router or via your network switches. There are a lot of different options available at the moment. Corded desk phones for basic use, cordless handsets allow you the freedom to move around, and conference phones for more advanced use. In some cases, business, there is no requirement for handsets at all. You can opt for a soft phone application that runs through your PC, mobile phone, or tablet. Some VoIP solutions offer enhanced features like call recording, reporting, and transferring of calls, which is especially useful if you have multiple departments or sites. We use 3CX here at Orbital, allowing us to be contactable whilst out of the office. You will notice a picture of a battery pack has appeared on the screen. The internet needs a power source to be able to function. Your new phone system will require an internet connection. So what if there's a power failure? You can install or use battery failovers, which will keep you connected in the event of a power failure. So you can still make your calls even if everything else has gone down. There are many advantages to moving to a digital phone system. With more people working remotely, staff are often moving around. With IP technology, you can take calls on your desktop, handsets, or mobiles. You can also use advanced call handling features such as instant messaging to deal effectively with contacts when they're not available to take the call. VoIP can be really cost effective and it's a scalable option. Flexible platforms can be tailored to your exact requirements. VoIP will require a good, stable internet connection. The call quality will only be as good as the Wi-Fi signal or the 5G if you're using a mobile device. I'm going to pass you over to Kim, who's going to take you through the different types of connectivity options available, and we'll also be discussing how to maximize your Wi-Fi coverage.
Ian. Hi everyone, thank you again for joining us this afternoon. So understanding the internet and how it works its magic is really important. It's something that we all take for granted, but it's so vital to all of our lives in so many aspects. So this diagram here shows life before fibre came along, where the copper lines carried our data. And back in the day, the internet was carried on the same copper wire as the phone line, meaning that only one line could be used at one time. And obviously, once this was realised to be problematic, they started making changes. But this was called ADSL. It all starts at the local telephone exchange. These act as sophisticated traffic controllers, and the digital data is converted into signals and that's sent through cabling to the final destination. The data moves from the exchange to those little green cabinets that we'll have all seen dotted around the streets. And then from here, it's sent out through further copper wires to the business or home. So these copper wires rely on electronic signals, which do slow down over long distances, which means that the speeds are much slower by the time the endpoint is reached, which means obviously in these modern times, this just isn't good enough. Then fibre to the cabinet, which is known as FTTC, began rolling out in 2009. This meant removing all of the previous copper lines that were originally running from the exchange to the cabinet and replacing them with fibre optic cables. So fibre optic cables are basically very, very tiny glass hairs that you can beam signal down at the speed of light. And obviously this improves services to the cabinet significantly. However, the copper lines were still in place from the cabinet to the final destination. And with everything nowadays being moved to digital and connected over the internet, these copper lines are far too restrictive and just not designed for the current level of traffic. So then Openreach began the rollout of fibre to the premises, which is known as FTTP, in about 2010. So this meant replacing the copper wires that still connected the cabinet to the properties with those same fibre optic cables. So speeds in these cables can travel around 40 times faster, and this is because of the use of light to transmit the data instead of the electronic signals. So you might see this being run from the cabinets or something called a distribution point or a splitter, which is like a small black tubular box. And it can come into the premises either through ducting underground or again using telegraph poles. So all homes and businesses connect to these distribution points, which are shared across the area. And this does mean at peak times you may see a reduction in performance, just as the same with copper cables, but it will still perform a lot better because of the capability of the line. So there is, of course, a way to have your own completely private connection, and this is something called a lease line, which I will talk about shortly. But essentially, it's strongly advised to upgrade your internet connection to FTTP as an absolute minimum to avoid disruption. This is still being rolled out nationwide. It's not available everywhere yet, but BT do expect 80% of homes and businesses across the UK will have fibre to the property by the end of 2025. Fibre to the premises, fibre to the property. Okay, so now we understand how the internet makes its way to us. It's important to understand the different types of connections that have available. So they've all got very unique features and various degrees of capabilities. There's 5 main types in total. Firstly, we have a lease line. This is your own completely private connection. We say it's like having your own private motorway. It gets you to your destination as quick as possible. There's no interfering traffic. This means symmetrical upload and download speeds, no lagging, no drops in speeds, and more than enough bandwidth to cater for everyone's requirements. Just after that, we have FTTP, which is delivered by those fibre optic cables I just mentioned previously. This is a shared connection, which does mean there is contention at busier times and it can slow speed slightly, just like driving on any regular motorway would. However, the speeds can still be very, very fast and are the next best thing after a lease line. We then have SAGIA, which is now superseded fibre to the cabinet, or FTTC. So this is those old copper lines that still haven't been replaced by fibre optics as of yet. These speeds aren't great for the times, but everyone should have moved away from these over the next year or two. If you do still have these lines into your property, there's various things we can do to help improve the speeds whilst you wait for fibre to be installed. And then last but certainly not least is wireless fibre. So this uses wireless technologies such as radio or satellite to transmit data. And this is ideal for rural areas or buildings with poor infrastructure. It's actually one of our unique selling points at Orbital, and we have built our own wireless technology infrastructure. It's available largely across Kent and is beginning to roll out nationally. And this isn't something that all the providers can offer. So as you can see, there's many advantages to having a fast internet connection, a lot of which are no-brainers. You know, in these modern times, the use of technology is ever growing. Almost every occasion, this now requires internet connection, which means a business's reliance on higher speeds is always becoming greater by the day. So I won't go through each point, but the main things to take away is that it will allow for an all-round smoother operation, especially as we see VoIP installed and other technology implemented. So there's a few issues that may arise after the switchover if you haven't prepared in advance. So we have an increased network load. The switchover moves all communication, so your voice, your fax, your alarms, to digital and IP-based system. So this adds more devices and more traffic to your existing internet and Wi-Fi networks, which can lead to slower speeds, dropouts, or lag, especially on older or underpowered routers. Insufficient Wi-Fi coverage. Many buildings, especially large offices, may have Wi-Fi dead zones. This is when telephony and other essential services become reliant on the internet. Poor Wi-Fi coverage can affect critical operations like your VoIP calls, security systems, or cloud access. I'm going to run through Wi-Fi coverage in the next few slides in a bit more detail as well, and how you can prevent this. And interference and signal congestion with more devices connected via Wi-Fi, smartphones, VoIP handsets, alarms, CCTV. There's a higher chance of channel congestion or interference, particularly in densely populated or shared workspaces, which can lead to unstable connections. Insecure legacy networks. Many older Wi-Fi setups are not optimized for modern encryption protocols or security standards. So as more sensitive communication moves online, post-switchover, these networks could be more vulnerable to cyber threats. Incompatibility with older equipment. So some legacy devices or systems, like analog fax machines, old decked handsets, may not function reliably over Wi-Fi based VoIP networks without the right adapters or hardware, which will cause connectivity or performance issues. Then we have dependence on power and internet stability. Wi-Fi enabled VoIP systems rely on a stable internet connection and power supply. Any disruptions, like during a power cut or router failure, can impact all communications unless backup systems are in place. And last but not least, there is poor quality of service configuration. Without correct prioritization settings, critical services like VoIP or alarms might lag behind less essential traffic like video streaming or downloads. So QoS configuration is essential post switchover to ensure business continuity. So mesh network. Mesh networks. A mesh network is a type of wireless network that is made up of multiple interconnected devices. They're known as nodes. So these nodes work together to provide a seamless Wi-Fi coverage across a particular area, like a home, an office, or even large outdoor spaces. But unlike traditional Wi-Fi networks that rely on a single router, mesh networks use multiple devices placed around your space. So they communicate with each other to form a network that covers a larger area. So in a traditional Wi-Fi setup, the signal strength will weaken the further you are away from the router, which leads to these dead zones, these areas with poor connectivity or no connectivity. Mesh networks address the issue by placing nodes in various locations, and each node acts as a relay point. So this ensures consistent signal strength throughout the entire space. It's seamless coverage because as you move through the space, your device will automatically connect to the nearest node, and the handoff is completely seamless, meaning you won't notice any interruption in your Wi-Fi connection as you move around. Another advantage of this is its scalability. Mesh networks are easily expandable if you find a certain area still has weak coverage. You can just add more nodes to the network, and they'll integrate with the existing ones and further extend the coverage. So then we have a hardwired access point. This does pretty much as it says on the tin. It's very similar to the mesh network, but the devices are cabled into a wall or ceiling instead. So to compare the two, the mesh network and the hardwired access point, the mesh networks are generally easier to set up because they don't require any extensive cabling. Hardwired access points do require Ethernet cabling throughout the area, which might involve more work during the installation process. However, hardwired access points often provide better, more consistent performance, especially in areas where wireless signals might struggle. So when would we use the hardwired access point? If you require the most reliable and the fastest Wi-Fi connection possible and true end-to-end speeds, when building or renovating a space, you can easily install data cabling. It's worth doing. Or in environments with many users or high bandwidth demands. So in summary, hardwired access points are a powerful solution for extending your Wi-Fi coverage. They have superior reliability and performance, particularly in settings where the wireless connection alone might not suffice. So just to show you an example of how this works. So this is an example showing you just one Wi-Fi router in the stairway. Obviously, as you can see, provides minimal coverage. This is still using one router and having one extra access point, still with limited coverage, but better. And this example shows you a seamless connectivity solution as you're walking around the space. So as I explained earlier, it's always better to have hardwired access points, or APs, they're also known as. But there are some situations in which you might have to install a mesh network instead. So I'm now going to pass back to Ian, and he's going to talk to you about what you can do to prepare for the switchover.
Lovely, thanks, Kim. So what should you do to prepare for the switchover? We would recommend reviewing your current connectivity and telecom setup, conduct a full audit of the services you have, how they're currently being provided and on what type of connectivity. Consult with your current providers to make sure they have a digital solution to meet your need. Upgrade to VoIP telephone services and fibre-based internet to future-proof your business ahead of the switchover. We would also advise that you test all of your services associated to your phone line. And of course, plan for a smooth migration ahead of the 2027 deadline to ensure there is limited downtime or disruption to your business and your services. So a little bit more about us at Orbital. We are locally based with national coverage. We have 27 years of expertise in the connectivity sector, and we can offer free advice and audits to assist you with the switchover. It's our vision statement to be the top customer-focused internet provider in the UK, and we are well on our way to achieving this. So we've got some previously submitted questions or frequently asked questions that I'm going to run through briefly before we open up the floor to your questions. So I'll jump straight into it. So what exactly is the digital switchover? Well, hopefully this webinar has covered this, but to recap, the digital switchover refers to the UK's move away from the traditional public switch telephone network, or PSTN, and the integrated service digital network, ISDN, to fully digital IP-based communication systems. And this will affect landlines, broadband, fax machines, alarms, and other analog devices. Will my current phone system still work? If you're using a traditional landline or an ISDN-based system, it will stop working unless upgraded to a digital VoIP solution. You will need to switch to a VoIP-enabled system that uses internet connectivity for voice calls. What services will be affected by the switchover? Traditional landline phones, fax machines, alarm systems like fire and intruder alarms, payment terminals, lift lines, emergency lines, sector specifics like healthcare pendants or telcare lines, and any ADSL or FTTC broadband reliant on copper lines. How do I know if my systems are compatible? You'll need to audit your current phone system, alarms, broadband, and other connected services. If they rely on copper lines or analog phone signals, they're likely not to be compatible and will need upgrading or migrating to a digitalized solution. Do I need to change my broadband too? Yes, is the short answer. If you're using copper-based products, or copper-based broadband like ADSL or FTTC, you may need to switch to SOGEA, FTTP or lease line connection depending on your business need. How will the switchover affect our internet speeds? The switchover itself Doesn't directly improve your internet speed, but it does require faster and more reliable connections for your VoIP and other services to work properly. Businesses with poor connectivity may need to upgrade to a fiber or improve Wi-Fi infrastructure. What about emergency lines and alarms? Many alarm systems and emergency lines rely on analog connections. These must be tested and upgraded to IP compatible solutions or have digital adapters installed to ensure uninterrupted service. What is VoIP and why do I need it? VoIP, Voice over Internet Protocol, is a phone system that makes calls via the internet. It's the future of business communications post switchover and replaces your traditional phone lines. It's often cheaper, more flexible and scalable. And will there be any downtime when I switch? If planned properly, there should be minimal to no disruption. However, businesses that leave it to too late or attempt a rushed upgrade may experience downtime, service loss, or communication issues. So at this point, we are going to open up the floor for any questions. Please raise your hand or put a comment in the chat and we'll be happy to answer any questions that you may have. Anybody? Any questions at all? I don't.
If you just want to come off mute and you can ask your question.
Hi, Nicholas. It looks like you've raised your hand. If you'd like to come off mute, we'd be happy to answer your question. No, Nicholas, we haven't.
Hi.
We can't. Hi, Nicholas.
Hi, Ian. Sorry about that. Ian,
That's okay.
I'm slightly confused about SoGear. Ian, I'm sorry about this. I'm not in IT by profession, as you probably know. But if I understood correctly, you're saying that SoGear is fiber to the cabinet. It replaces the fiber to the cabinet and copper to premises. Is that right?
So yeah, I'll try and explain it a little bit clearer. So historically, internet and phone lines, it was almost like a dual line that ran in. So you had a copper portion and an Ethernet portion. The copper portion was for your phone line. The Ethernet portion is for your internet, which is why historically there's always been like two charges. If you look at your bill, you would have had a charge for your phone line rental and a charge for your broadband. So the SoGear removes the copper portion. That degraded service, those copper lines that are now really, really old, will be removed, leaving just the SoGear or the Ethernet part of that connectivity in place until fiber is available.
Okay, and then at some point, fiber will make its way from the cabinet to the premises.
To the premises, exactly that. Yep.
Okay, right. Other question, if I may, is currently in my home office, I have voice over P, and that's voice over IP, and that's through BT and their BT Cloud voice application.
Yep.
It's not been great, to be honest, but I'm going to blame that on BT. And there may be some infrastructure issues here in my home, so I don't want to pour cold water on the whole thing. My question is, are there any metrics for call quality provided with your SoGear and VoIP services, so that you can actually, so I can actually say, look, Ian, the call quality isn't what we're expecting. These are the issues we've got, because at the moment I can't easily have a technical conversation with BT and point to anything that may be wrong.
Yeah, so absolutely. I mean, VoIP, it does rely on a stable internet connection, and depending, I mean, we don't know your setup and how your VoIP's been set up. There are many ways of setting it up and many tests that can be done to try and ascertain where that problem is. Without, I mean, it's probably a further conversation that we need to have kind of offline, Nicholas, to understand that, so I can answer the question fully for you. But
yes,
it's certainly something we could look at.
Yeah, and to be honest, you know, my home office is not through you. Your service in our church office has been great. I'm not asking you to fix my BT problem. That would be unfair. But I was just interested when we transition in our church office, if we have similar problems, are the ways that we can measure the quality of calls and more easily identify where the problem may be. That's all. But I think you've said that there are those tools in existence, so that's great.
Yeah, absolutely. And again, the support team here would help sort of identify where those issues are and work with you to rectify them if it was on our service. So
okay, thank you.
No problem at all. Has anybody else got any questions? Again, if you'd like to just raise your hand or pop a comment in the chat section, we'd be happy to answer.
Hi Rose, I can see you popped something in the chat box. So when can we have someone to attend or advise us on anything we need to do? We're still on a copper wire here around the cathedral, if I'm not mistaken. Okay, so we actually have recently installed our own FTTP into, I'm assuming you're talking about Canterbury Cathedral, into Canterbury town centre around that area. So it may be the case that we can potentially get FTTP to you. Obviously, so what we'll do next is we'll put our details up, or I'll take your details down and I'll get in contact with you and I can have a little look into what's available for you. And we can advise on the next the best thing for you to do and your current situation. So yeah, I'll get in contact with you after this. Yeah, that's fine. Thank you. Write that down. Yeah, yeah, we'll get in touch with you about that, Rose. Is there anyone else who has any questions? Okay, well, we're just going to pop our details up on the screen. So if there is anything that it pops into your mind after, please feel free to give us a call or an email. And we'll leave this up for a few minutes just to give you a time to jot it down. But thanks very much for joining us today, and we hope it was useful for you. Thank you.
Thanks very much.